Assalamu alaikum. Good morning, everyone. This is chapter 7 about logarithmic and exponential function. I'm talking today about the main properties of logarithmic function or natural logarithm and exponential function, what's the relation between them, and I'm going to solve some questions on using rules of logarithm, like write this expression in a single logarithm and also find the first derivative of some functions like the one you can see now. Let me start with you. First of all, the logarithmic function, the ln x, come from what? Look at this curve, please. This is a part of the curve 1 over t, or the exponential function. You remember the function f of x is equal to 1 over x, expressed as two separate graphs, one in the first quadrant and one in the third quadrant. If we take the positive part of x, which is a domain of the ln function, we can see this curve now, 1 over t. The ln is defined, as you see, as integral 1 over t from 1 to x, where x bigger than 0. So the y equal ln x. Ln x is called natural logarithm. Its base is e, and e is about 2.7, something like that. You can find that value, and its irrational number belongs to q prime. The ln e is defined as integral from 1 to x, 1 over t dt, and x is a positive value. When you integrate 1 over t, the answer is ln x. Again, the integral of 1 over t is ln t. Let me say t. Okay, the ln t. And ln t, the boundaries of the integral from 1 to x. So it's ln x minus ln 1, which is ln x minus 0, which is ln x. So the ln x is simply integral of 1 over t dt from 1 to x. The ln function, this one, when you graph the ln function, this red graph is the ln function. As you see, the domain of the ln or the logarithmic function is x bigger than 0, and the range is negative infinity and infinity, or r. In the other side, it's the inverse. The inverse of the ln function is e to the power of x. Why? I'm going to explain now why the inverse. Consider the function y equal ln x. I want to find its inverse. Find the y power negative 1 or inverse function of this one. First of all, switch x and y. Just write ln y is equal to x. Okay? And after that, just express this logarithmic equation into exponential form. You know the base of ln is e. So just write e power x is equal to y. Again, you just write e power x is equal to y. And this function now is the exponential function, and this is the inverse function. As you see, the inverse function, e to the x, its domain will be negative infinity and infinity, and the range will be y bigger than 0. For any function and its inverse, always will be symmetric about the line y equals x. Okay, so each point here, x and y, will be y and x in the inverse. As you see here, look, this point, 1 and 0, it's 0 and 1. The flipped one lies on the inverse function. And also, the domain of the function is the same range of its inverse. And the range of the function is the domain of its inverse. This is true for any function and its inverse, okay? The next part here, I have some rules for logarithm. You have to see it here. The rule number 1, ln 1 is 0. Since the curve of ln pass through the point 1 and 0. So ln 1 is 0. Ln x is positive when x bigger than 1. And ln x is negative when x belongs to 0 and 1. Okay, for any n and m positive numbers and k any real number, I have ln mn is ln m plus ln n. Okay, and the ln m divided by n is ln m minus ln. So ln the product is ln plus ln the division is ln minus ln. And finally, ln m to the k is k ln m. And in number 4, I want to talk about the product of more than two terms like m, n, k, something like that. If you have a product of two amounts, you'll find it's len. So it's simply len m plus len k plus len n. So any order, sorry, yeah, just write any order. Okay, len plus len. But the division, you take the quotient only of two amounts, because since the division cannot be between more than two terms. Okay, let's go to this question. Express E equal 3 len x plus 2 len y minus 5 len z plus len w using single logarithm. First of all, just write E is equal to, you can rewrite 3 len x according to the third law of the len x power 3. Just raise this 3 up here. Plus 2 len y, you just write it len y squared. And you can this also add, you can write beside it len w, len w. And finally, this minus, just remove it here, minus. And the 5 len z, you can write it len z power 5. The first three terms, len plus len plus len, you can just write only one len and multiply this all. X cubed dot y squared w minus len z power 5. And now I have len minus len can be written as len the division. Len x cubed y squared w over z power 5. Now I wrote this expression including four terms into a single function of logarithm. Its coefficient is 1 here. The coefficient is 1. Next question here. I have some functions. I want to write its derivative. Let me start. Number 1, or question A. I have A equal x squared plus x plus cosecant x minus len absolute value of 2x. The derivative will be y prime equal 2x plus derivative of x is 1 plus derivative of cosecant negative cosecant x cotan x. You can find this from the formula booklet of the derivative of trigonometric function, minus the derivative of linear function is 1 over the function multiplied by the derivative of 2x, which is 2. So again, we can rewrite the answer as 2x plus 1 minus cosecant x cotan x, and derivative of 2x, just try to remove this one, just write 2, can be written as 1 over x. Okay, 2 divided by 2 is 1, so you have 1 over x. B, this one, sine x, len cosine x considers the product of two functions like this. So you can apply u dot v, derivative of product of two function u prime v plus v prime u. Okay, so derivative of sine is cosine x, y prime is equal to, or dy by dx is cosine x. When you derive the first one, just multiply this. The first one you multiply only the second one, len cosine x. Okay, plus just to keep sine x this time and derive len cosine is 1 over cosine x times the derivative of cosine, which is negative sine x. Okay, so the answer, as you see here, you can, just multiply again cosine x. You can just arrange your answer into len absolute value of cosine x. We always take absolute value for the function in front of len to be sure that this number is positive, since the len defined only for positive numbers. And this is minus because you have a sign here. Just to multiply sine by sine will be sine squared x over cosine x. Okay. Number C, you can also len absolute radical x. You can find it. And the D, we do it now. We'll make C and D now. Okay. C, y equals len radical x, which is, you can just write it len x power half. Okay. So the derivative dy by dx, or y prime, is equal to len of function is 1 over the function times the derivative of the function. The derivative of x power half is half x power negative half. We write this one as 1 over root x. You can bring x bar negative half down also as a root x, and also 2. I have 2 here. So the answer is 1 over 2x. This is answer. Root x and root x is x, and x bigger than 0, of course. Question D. I want to drive this. You remember the rule: v square u prime v minus v prime u. This is a rule for driving u over v, a function. This is the form. So apply this form. Derive x is 1 dy by dx. Derivative of x is 1 times the ln x minus keep x, and the derived ln is 1 over x. And down, you just write ln x all squared. Okay? So answer ln x minus 1 over ln x all squared. And this is the derivative. Okay? If we go through this paper and solve activity number 2, express, this is the same as we solved now. This can be written as ln x squared, very easy, plus ln y cubed minus ln z power 5. You have to bring these all coefficient as a power of the variable you have. Now, ln plus ln is just ln the product. Yeah, you can add first the first 2 terms. Ln x squared y cubed minus ln z power 5. And after that, ln minus ln is ln the division. Only just write 1 ln and divide x squared y cubed by z power 5. Now this is answer. I rewrite this expression as a single logarithm. As a single logarithm with coefficient 1. Express ln this all in terms of ln A, ln B, ln C. A, B, and C represent positive real numbers. So just the same way as we solved right now, okay? You can write it step by step, okay? 2 ln the numerator a cubed 5th root of b squared a minus ln c squared b cubed, okay? And after that, this is a linear product. It's ln plus ln a cubed plus ln 5th root of b squared a minus this product will be written as a ln c squared minus ln b cubed, because this negative will be distributed over the ln c squared plus ln b squared will be in this form. So you simply write 3 ln a plus this 5th root means 1 over 5. Yes, 1 over 5 of ln b squared a, okay, and minus 2 ln c minus 3 ln b, okay? And also here, you can rewrite 3 ln a. Here is a product ln. The product is ln plus ln. If we have fifths multiplied by each. So the first one will be 1/5, sorry. This 1/5 times 2 ln b plus 1/5 ln a, okay? And these two terms still exist, this and this, minus 2 ln c minus 3 ln b. So finally, you can add the like terms here. Ln a, look at ln a. This is ln a, this is ln a. What else you have? Only these two. So 3 plus 1/5 is 3 and 1/5 ln a. And the ln b's, you have 2/5 here, and you have 3 here. Just 2/5 minus 3 is what? 2/5 minus 3, just multiplied by 5, multiplied by 5. So 2 minus 15 is negative 13 over 5 ln b. What I solved now is this term and this term. I solved them together. And finally, ln c, you just write it in the end, minus 2 ln c, and this is the final answer. In this question number 3, I want to express len 2592 in terms of len 2 and len 3. Just write len. You go to the calculator and factor this number. You can factor it easily by using calculator. I have some calculators that has a factorization pattern. You can factor or not, like this expression, like this one. So just write 2592 divided by 2. Continue dividing until you get a 1. When I say 2592 divided by 2, you get 1296, still divided by 2, 468, divided by 2 will be 234, divided by 2 will be 1, 3 divided by 2 7. The 117, 117 is divisible by 3 this time, divided by 3, which is 39. Oh, no, something wrong I did. I don't know. So 1296, again, 1296 divided by 2. The answer is 648. Yeah, this is 648, sorry. This one is 648. I'm sorry. This one, no. Okay. And remove this one. This is 648. 648 divided by 2 is 324. Still divided by 2 is 1, 6, and 2. Still divided by 2 will be 81. And 81 is 9 times 9. Each 9 is 3 times 3. Yes? So how many 2's you have here? 1, 2, 3, 4, 5. So you can write len, this number len, 2 power 5 times 3 power 4. And the product is len plus len 2 power 5 plus len 3 power 4 is equal to 5 len 2 plus 4 len 3. So I wrote the expression in terms of len 2 and len 3 only now. Okay, this is all question I have today. Thank you so much and see you next time. Goodbye.